Welcome you all. Today we discuss marginal PDF. So in last video lecture we discussed PDF for a pair of random variables, and the main idea there was that we have two random variables, and in continuous case, as you know, that we have to take the double integral for calculating the PDF. Now here the marginal PDF. So for marginal PDF, so the main idea is if a pair of PDF is given to you, how you calculate for a particular variable in that pair PDF, then that PDF is known as marginal PDF. Now let's look at the theorem to define the marginal PDF. So the basic idea about this theorem is that if you have a pair of random variables, that is x and y, so with joint PDF is given to you, so you must have joint PDF that depends upon x and y pair of it. If you want to calculate the PDF, marginal PDF for x, in that case you have to take the integration from minus infinity to infinity for y, then you will of joint PDF you will get the marginal PDF of x. Similarly, for marginal PDF y you have to take the integration from minus infinity to infinity with respect to x of the joint PDF. So this is the way you can calculate the marginal PDF of x and y using the joint PDF of x, pair of x and y random variables. So the main idea here is that, as you know, that when we take the whole range from minus infinity to infinity, so this means that we assume that the probability of y is 1 in that case. So that's why to make this, to just look for x without considering y, so in that case we have to take the integration from minus infinity to infinity. So for x we have to do integration with respect to y, for y we have to do respect with x. So the proof is very simple. We just plug in the formula and apply the probability definition for the PDF, so we can easily prove this theorem. Now let's to understand this idea, let's consider an example here. So the main idea, remember this, the whole basic method that is used in calculations here in pair of random variable is the way you can represent the limit. So if you look at this example, and it says that we have a joint PDF x and y given to us as 5y divided by 4 with range minus 1 to 1 and y is from x squared to 1, 0 otherwise. Now we have to find the marginal PDF of x and y. Now when we have to look for ranges, so for marginal PDF of x we have to do integration with respect to y from minus infinity to infinity, but y is defined with this function, that is y is less than or equal to 1 and greater or equal to x squared. So we have to do a graphical representation of x squared. So if you look at x squared is actually a parabola, so you can have to represent limits graphically, then you can put those limits to calculate the marginal PDF after applying the theorem that we study for marginal PDF using the joint PDF. So but in case of x, we have to from here we know that x square is less than y, so from here we easily calculate that x is between minus under root y to y, so this is the limit for x. So let's see how we solve this. Now in this example, so I told you the basic idea is to plot this x square. So look here, this is the x square curve. I plotted on x and y axis here. This is the horizontal is x and vertical is y. So this is the limit. This is the range of the limit that is that represent x square, and this is the 1. So y is vary from x square to 1. Now we have to put the for x we have to put the theorem. From theorem we know that we have to put the limits of y from minus infinity to infinity, but the function is defined only in this range, so we have to change our limits from x square to 1. So look here, we start from y is equal to x square to y equal to 1. Now plug in the join PDF and do with integration with y. When we did that, we get this result. So this is the marginal PDF with respect to x. So when we plot it, so this is the result of plotting this curve. Okay, now we can represent this. Actually, this is the limit, and this limit satisfies with the limit of x. So we just plug in limit of x here and 0 otherwise. So similarly, we have to calculate for y. So for y, we have to, here we look vertical limits. Now we have to look the horizontal limits. Horizontal limits with respect to, look here, we have to find limits here and there. So we can use this equation y is equal to x square. From here we calculate x, that becomes under root plus minus under root y. So we use that limit. Now if we move to next, look here. So this is the main, this is y. We have to look in terms of horizontal, how y look like. So y is the minus under root y and plus under root y. I told you how you calculate it. You calculate using the formula y is equal to x square. From here we get these two limits. Now these are the limits, and again we have the joint PDF value, and we do integration with respect to x. When we did that, we get this result, and this is only possible when y is between 0 and 1, because this is the variation of the y we get from 0 and 1. So this is the way you can calculate the marginal PDFs. Now this is the quiz that we will do it to further analyze and understand our concept. So based on this concept, we have probability density function of a random variable x and y, which is given to us. Now question is again, find marginal PDF of x and y. Now for marginal PDF x and y, again look here, we have to look the limits. Now limit, there is no function defined, so it's very easy. So for x we have to take the limit of y, for y we have to take the limit of x and do the integration with respect to y and x respectively. We can calculate marginal PDF for x and y. Now look at the solution. So this is the formula. Now we have very simple limits with respect to y, that is 0 to 1 dy. We solve it, we get the result, and we put the limits of x. Again for y we have to put the limits of x here, 0 to 1 again, and we put the limits of y. So this is the way we can easily calculate the marginal PDF. So this is the basic idea behind marginal PDF. Now the next concept that we will look at is independent random variables. Now if you remember, in case of discrete random variable, when we say that a pair, if we have a random variable x and y, they are independent if and only if we take the PMF of joint PMF is equal to multiplication of marginal PMF. So similarly, in case of continuous, the joint PDF must be equal to multiplication of marginal PDF. So if this case holds, then we say that x and y are independent random variables. Now to look at, we have an example here. So x is given to us, this is y, so these are actually marginal PDF given to us. So for joint PDF we have to multiply this, and we know that this is from equation from the previous example, that is 5.2. so if you go to 5.2, you see that the joint PDF is equal to 1 when x is between 5 and 6, and again y is between 6 and 7. So when we do the multiplication, we easily know that they are equivalent, and so x and y are independent. Now there's another example. So in this example we have to show that x and y are independent. So for this independence, we have to first calculate the marginal PDF of x and y. So if you remember, we just discussed that how we calculate the marginal PDF. So for marginal PDF, so we have to, for x we have to use the limits of y, for y we have to use the limits of x and do the integration from those limits, and we calculate the marginal PDF of x and y. So you know that this is actually the basic application of marginal PDF. that we can use this for identifying the independence of two random variables. Now look here, when we do that, we get this marginal PDF for X and similarly this for Y. So we just know that when we do the multiplication of these two, and these pairs are independent. Now similarly for this question, we have to find that are these independent or not. No, again the main idea here is to calculate the partial PDF of U and V. So for U and V, look here, so the main idea here is that there's a relation that defines between U and V. So we have to use these relations to find the limit. So we know that the lower limit is 0 and the above we can easily find using this relation. So for V, we just calculate V is less than or equal to 1 minus U. So and put the values from here. So this is the way we can calculate the partial PDF of U and V. Now look here. So we use 0 to 1 and we just plug in those values and we calculate this for U and V. Now here we are not independent because when we do this multiplication we are not getting this result here. So this means that these two are dependent random variables. Now again another example where we have a uniform random variable and we represent y is equal to x plus z, and where we have x is a Gaussian with the zero mean and standard deviation, and similarly we have z another Gaussian random variable. So the main idea is that we have to find that x and z are independent or not. So we just do the same thing, we just write the partial PDF of x and y and just do the multiplication. We get this joint PDF. So from here we easily know that this is equal to their multiplication of partial PDF. So this means that x and z are independent random variables. Now this is the quiz, and here quiz is based on two questions. So first one is based on a part that is based on the discrete random variable. So we have these two discrete random variables. We have to prove that x and y are independent. Similarly q and g are independent. So for that case what we have to do, we have to find the partial PDF for PMF for x and y. After that similarly for g and e, and then apply the theorem that we studied for independence. Okay, now for this solution, look here, we know that the joint PMF is not equal to the multiplication of partial PMF. So from here we know that x and y are not dependent. Again q and g, this is the case true for those because every pair satisfies this condition. So q and g are independent random variables. So this will just give you an overview that we already discussed in previous chapter, that how we can calculate for continuous and discrete random variables. Now we move to the next part of the quiz that related to the continuous one, and it's very interesting one. It says that assume that you have two random variables x and x1 x2, and with probability density we are given with the partial probability density function for that. We say that this is the partial one. So what is the joint PDF? So joint PDF is very simple because if we put x1 here, this becomes the x1 PDF, partial PDF. Similarly we put x2, it becomes x2. After that we know that because it says us that they are independent, so this means that we have to multiply these two. When we do multiply we get the joint PDF. So there's another term here, identical. What do you mean by identical? Means that the equation of the partial PDF is same. So look here, we just do the multiplication, and because the property of independence, we easily calculate that this is a this is the joint PDF of X1 and X2. Now here we will stop this video lecture, and we will continue upon the expected values of function to random variables in coming lecture.